All right, in this video, I'm going to go over parametric constraints. You've already been using them to some degree, but I'm going to show you how to go that next step and use parametric equations. So parametric constraints are used to control the size and location of the geometry. They may take the form of simple numeric values, such as 2 inches or 25 degrees. They may take the form of abstract algebraic formulas, such as this equation here, the d2 times d0 divided by d5. And what these are is the actual dimension. So the very first dimension you ever put on a sketch is actually d0, and then it goes up from there. So this would be like the 6th dimension that was added to a sketch. Okay. Okay, so it could be tied to spreadsheets that allow for more complex mathematical formulas, but we're not going to get into that in this course, but it can be. Right. Now, parametric equations, we are going to touch on that in this video, and then you're going to make something using those parametric equations. So it's an algebraic equation that uses variables and let me try that again. Algebraic equations that use variables can be substituted for individual numeric values. So here's just those dimensions that I was talking about. All right, the resulting dimensional value may change, but the formula will remain the same. All right, you're going to use symbols like adding, subtracting, multiplying, and dividing. Most of the time for parametric equations, you're going to be multiplying and dividing because you're wanting kind of ratios. You're wanting to size something up or down. Here's a scenario of what I'm talking about. All right, a child's proportions are similar to those of an adult. A chair could be dimensioned so that changing the seat height uniformly scales all the other chair features. So in that case, we're looking at ratios, and that's what I'm talking about. Most of these equations are going to be multiplying or dividing because you'd want to scale this down but have those same ratios left. All right, so if you have something like this, you've used some parametric constraints with the numbers. Those are going to be the same. All right, and it says all dimensions given a designation starting with D0. So that means that this very first dimension was D0. All right, they made the rectangle D1. They dimensioned that. Then D2 was that extrusion dimension. Right, and it looks like D3, I don't see that on here. Oh, it's a plate taper angle. Okay, and so on and so forth. So that's each of these dimensions has a designation. Okay, so, and that's what it's talking about here. So I'm going to go ahead and stop the PowerPoint part and go on to Inventor. So if you'll go ahead and open up Inventor if you haven't done so already. Okay, and we're going to make something that looks like this. This would be a flag holder. So say I have a little flag, a little American flag that I want to put on my desk. It's fairly small, but then once I've designed it, I'm a company and I want to mass produce these, maybe I want it to also be able to be a larger flag holder. Maybe I've got a large American flag that I also want to use. This may not be the best design, I just was trying to go simple, but this is the concept that we're going to go with. Okay. So go ahead and open up a new part. Okay, and we're going to start a sketch, and I'm going to start with that rectangle on the bottom. So I'm going to pick this plane here, so that way it'll be in the right formation. Okay, I'm ready to do my rectangle. I'm just going to draw a rectangle, or well, actually a square is what it's going to end up being. But I'm just going to draw it and start with my dimensions so that I can see what dimension is what designation. So I'm going to say dimension. And this first one here, see how it says D0. This is the one I'm going to give just a number to. So maybe I'm going to make that, let's say 2 inches. Right, and hit enter. So now the second one, right, I'm not really sure where D1 went. It's probably this one over here. All right, so now this is D2. At this one, I'm going to make it equal to D0 because I want it to be a square. Right? So now we can tell, like if I come over here and I change this to 1, notice how my D2 also changes to 1. Right? I'm going to change it back to 2 because that's originally what I was wanting it to be. Right? So I'm going to click Finish Sketch. And now I need to extrude this. And these are all going to be thought of as ratios. So I'm going to only be using multiplication and division. Because if I add, say, 2 inches, when we start getting into the ratios, then adding 2 and say I went up to 24 inches, it's such a small number compared to if I started off at 2, if that makes sense. We're going to want to multiply and divide everything with our equations. Okay, so I'm going to extrude. Okay, and I'm going to change this distance to D0. And I'm going to divide it, let's say maybe by 4. No, that's not quite big enough. Let's divide it by 8. That's a pretty good size. Let's kind of look at 10 and see what that looks like. All right, that's more what I want it to look like. So I have D0 divided by 10. I click OK. Now I'm ready to add the circle on it. Actually, let's go ahead and do the fillet. Kind of make that a curved surface. So I'm going to click Fillet, and I'm going to click all the edges that I want to fillet. Right, and now I can't make this just 0.125 because say I make this larger and it's like 2 foot instead of 2 inches, 0.125 is not going to look the same. All right, so I'm going to make this D0. Let's go ahead and divide this by 10 as well, just because I had done that with, I did that with the height. So if I want it to go down to the bottom, that would also be divided by 10. And click OK. All right, just to kind of show you, you don't have to follow along with this part, but just to show you, if I edit this sketch, and I change this first number to say 24, like we had said, and click Finish Sketch, notice it still looks the same no matter what. All right, so I'm going to undo that, so that way I can go back to the way it was. All right, so now I want to draw the little part that comes up to put the flag in. So I'm going to put a sketch right here on top. I'm going to go ahead and draw a circle. And let's say maybe, let's go D0. And every time I happen to be using D0, but you could use D1, D2, D3. You don't always have to go back to D0, as you saw in the PowerPoint. So D0 divided by, I just happen to have chose to use my first dimension. Let's divide this by maybe, no, let's do maybe 3. Okay. Now I need to do another circle. And we'll do this one maybe by, let's see, D0 divided by, usually you'll have some dimensions and some actual ratios you figured out. I'm just kind of winging it. Let's go ahead and say divided by 4. Right, now I'm not done, and the reason why is because I've got to constrain this so that it stays in the middle. If I change that dimension again to make this say 24, these circles are going to stay kind of right over to the right, or the upper right hand side, and you don't want that. You want these circles to get larger, and you also want them to stay right in the middle. So I'm going to have to somehow constrain it right there in the middle. So I'm going to say dimension, and I'm going to dimension this to D0 divided by 2. So that way it's halfway in the middle. And then this one, I'm going to have to go the same. I'm going to have to do the same thing in the opposite direction. All right. So, and then I'm going to say D0 divided by 2 again. So that way I know that if I change this dimension, these circles are going to stay in the same spot. I finish that sketch. And now I'm going to extrude this circle, these two circles, so that I can put the flag in the middle. And let's say, yeah, why don't we just make them the same distance as the first one, right? Because we need it kind of long. All right, so that way the flag doesn't kind of tip over. I'm going to click OK. All right, so now if I want to go back to that sketch 1, and I want to edit that, change it to 24, I can check it and make sure that it does the same thing. Okay, and yes, it does. All right, no matter what, if I change that D0, the whole thing is going to be a ratio of it. And like I said, it doesn't always have to be D0. All right, sometimes it might be another dimension. You just go in, and like if I look at this, I can tell what dimension something is. Right, because when I do this, it tells me that dimension would be D12. So I can go back in and look. But obviously, I want to go ahead and get rid of that because I don't want things to change when my parametric equation is done. So I'm going to click Edit that sketch. All right, another way to do this now for the assignment I'm getting ready to give you and show you, I've got a little more to show you, but the assignment I'm getting ready to give you, I want you to use parametric equations to do it. But another way that you can do a scale size of it is, say you go in and let me just go ahead and start a new part. Actually, follow along with me. Open up a new part. Right? Then I can go over to where it says Derive. All right, so I'm on a new part and I want to derive another part. So I click Derive and I'll just go in and it really doesn't matter. I'd like something that maybe you can see a little bit better. Let's go ahead and do this one. All right, so go in and just grab a part of yours and click Open. And now I'm going to put this in, but I need to derive it. All right, so what do I want the scale factor to be? Maybe I want it twice as big, 10 times as big. Maybe I'm going to do a life-size one or whatever. I'm going to put in that scale factor. So, say I want it to be like 10 times as big. As you can tell, it went much larger. And I would click OK. All right, and I can prove this by going in to Inspect, get my distance, and then I can get that distance. And it's 5 inches now, all right, which is 10 times as big as it was before. Okay, so you can do this parametric, I guess, in two different ways. This really isn't considered parametric. The parametric equations is when you actually write out those equations, and we go in and we just change one number. Derive is if you already have the part made and you want to scale that part, then you can go in, you can scale it to a different size. Okay. Now let's go back to our flag holder. All right, that flag stand. And I want to show you now how to do a stress analysis on it. Okay. So go to Environment and go to Stress Analysis. All right, so basically if I put some force on this, is it going to break? Okay. So I'm going to create a simulation. Okay. For this particular assignment, we're just going to do a basic simulation, a basic stress analysis on it. Okay, so I'm not going to change anything. I can change the name so later I can go back and do that same simulation if I wanted. All right, so now I'm going to click OK, and now it gives me all these other options. The first thing you have to do before you add pressure to something is you have to tell what the fixed point is. My fixed point, I'm going to say it's going to be stuck on the bottom. Okay, that's my fixed point, where it's not going to budge. It's not going to move if force is added to it. Right? Enough friction is on it. And so I'm going to click OK. So that's one of the first things you have to do is pick where that fixed point is going to be. Now I'm going to add force to it. I think I'll go ahead and say that force is being added maybe right here where the flag is kind of bending and moving. Right? And then I have to decide which direction. Okay, either direction. I'm going to go ahead and leave it the way it is. And I'm going to decide how much force is actually acting on it. So this one is a 24-inch, because remember I had made mine larger, so maybe a flag would be, I'm just going to guess and say 20 pounds. That might be a little bit overinflated, but I'm just going to throw 20 on there. Okay, and I'm going to apply that. Now I'm ready to do this simulation. So there's so many other things you can do, but I'm just showing you a basic one that you need to know for this class. All right, so I click Simulate. Oh, yes, I forgot to also have you do. Now you need to change the material. All right, so we can either go over here to Eye Properties and go to Physical, or we can go right here in the tool bar at the top, and I'm just going to make mine steel. You can make yours whatever material you want it to be. Okay, because it can't tell how much stress it can take if it doesn't know what material it's made out of. So I had just forgot to make the material. So you need to decide what material, decide your fixed point, do your force, tell how much force, and if I hover, see how it kind of tells me exactly what to do. All right, now I'm ready to simulate it. And I'm going to click Run. Okay, so now it tells me right here, red is where it would break. Okay, over here I've got a little bit of red as well. So let's animate this so that we can kind of watch what happens. I'm going to click Animate, and I'm going to click Play. And kind of see what would happen. I can make this go slower if I want to watch it a little bit slower. Okay, I can also do a report on it if I wanted. But that's how you do your stress analysis. All right, so maybe I want to go back and change something. Say, well, boy, that's going to break with just 20 pounds. Some things that you might go back and do. Maybe I could put a fillet here. Okay, and maybe want that fillet at divided by, say, 2. No. Obviously, that wouldn't have worked. I don't know what I was thinking. I'm going to say divided by 5. So apply that. And I'm going to go back to Environment, Stress Analysis, and I'm going to run that same one again and see what happens. Okay, so it didn't help. But you could go in, you could change things, and then see if maybe it would be better off. Okay, if it had better results, and maybe that 20 pounds would then actually work with your with your flag stand. All right. So now what I want you to do as your assignment is I want you to make Thor's hammer. Okay. So it's not wanting to go. I have Thor's hammer on here. Hold on. Okay, so here is the one that I made. Yeah, there's a very good chance you could make one that looks a lot better than this. But your assignment now is to go in, make Thor's hammer using parametric equations. When you're done, let me know so I can come over and I can change one of your values so that it will make it bigger or smaller. And before you call me over, make sure that you have tried it because like this circle on top and the handle all needs to stay in place whenever you change that one dimension that you would need to change. Okay?